All right, then. So I want you all to still watch that video that I sent you. Some of you watch some of it already. After this session, it will be even easier to watch. Right? So, because of the limited time is on 5:40, I'm gonna go straight to the question because I know that the explanation in the video covers everything. Get me? While I'm doing these questions, I will still like um give some explanation, and anything you don't understand, you let me know. So as I do a couple questions, and I say that okay, I come to a question that some of the content is repeated because they don't have many different ways of asking these questions in statistics, believe me. So they do one or two or three of the papers, then the next one I might ask you to do it before I do it. All right? So we can just clear this topic today. So that we can go on now to the next topic, which is the probability theory on Tuesday. All right, so that is the whole idea. All right. So I'm gonna go straight to the past papers. And I'm working on the premise that you who have not yet watched that video will go and watch the video. All right? You will go and watch that video. All right. So it's on my channel, that's the same as Statistics 1 on the channel. All right, but I sent you the link. Send you the link. Yeah. So Statistics 1 is the name of that. On the 2012, I also done that video. So I'm going to start at 2024 on this paper. So this is 2024 exam paper, ADMATS 2024. And I'm going to go straight down to the statistics question, which is the last question on the paper. All right. Down here. The good thing about statistics at this level is that all that you learn in statistics at CSET, well, not everything, they don't set everything, they don't test on everything. But your knowledge from CSET is also valid up here, valid in ADMATS. Right? So like the quartiles, interquartile range, mean, mode, median, all those things still valid. Group data, ungroup data, discrete data, continuous data, all those definitions. But all of those things are covered in that first video. So go and watch that first video. All right. Let's go straight to the question. This question says, the heights of 35 students at a nursery were recorded to the nearest centimeter. The data is shown below. Now, the first thing you want to do when you get data is check if it is in ascending order. When you're doing statistics and you have a number of data, you want it always to be, it can be descending order as well, but we tend to work with ascending order mostly. So your data, just work with ascending order. So you want the data to be in ascending order before you try to analyze it. In particular, before you try to find your quartiles, your interquartile range, your median, and if you're going to find your percentiles, which I also explained in that video, or your deciles, you want the data to be in ascending order. Right? Quartiles, deciles, percentiles, they are really position of the values. Right? What position? So for example, the first quartile is the position of the value that is in the 25th percentile position, 25% of the data. Right? The value that is in it, but you have to put the data in ascending order first. As I said, I don't want to be repeating stuff that is already in that other video. I really want to focus on doing it, but you want to check that this data in ascending order, which it is not. This data is not in ascending order, right? All right. But what they wanted to do, they wanted to display this on a stem and leaf diagram. All right. So a stem and leaf diagram is a diagram where the 10 values are the values, you have the 1 values and the 10 values. So those values are placed in a column, which is called a stem. And then the 1's values are placed in another column that is called the 1's. Right? That is called the leaf. So the stem and leaf diagram. So the way of showing all of this data in a compact way, and you don't have to be repeating these numbers. All right. So if you look at it, look like the lowest in terms of the stem values, you're looking for the tens values. That might be a 6. So it looks like, see, 61, I have 62 down here. There are no values in the 50s. So like the lowest value on this on the stem side is 6. So you do it like this. You have a straight line. Over here you have the stem. You have the stem side. And you have the leaf side. And you put in like the 10, well, the 10 value. So that starts at 6. And it looks like it goes up to 11. All right? So it would be maybe 6, 7, 8, 9, 10, and 11. That's the stem side. Then you have the leaf side. And we can go valley by valley. 61. So you're gonna put a 1. But you want to put them in ascending order. That's the problem, you know, with this not being in ascending order. That's why it's good to put them in ascending order. So you're gonna have to search for the values because you're supposed to put the values out here in ascending order just the same. You get me? So that's the problem with this one. It's not in ascending order. And then there are 35 values there. I don't think 6 is friendly. But the numbers in the 60s are this one, and as you find them, you want to make sure that you mark them off, right? So these are the numbers in the 60s. So another number in the 60s, you can search down column by column until you find them. I think the easiest way to find them is to search down the column. Each column. Treat this as a column, another column, another. So looking for the numbers in the 60s, 60 something. Those are the only 3 I'm seeing, right? You see a 67? This one, good. All right, beautiful. 67. All right, go down here, go down here. Oh, so 65 right here. Go down here. All right. All right, so those are the 60s, right? So the lowest one is 61. See here, 61. Then 62. There are 2 of them, 62 and 62. So you put a 2 right here for 62, and another 2 for 62. And then you have 65 right here. So you put a 5 here for 65. And you have 67, you put a 5 here, a 7 here for 67. And that now would have covered the 60s, the numbers in the 60s. Let me shift this up. Let me shift this up a little. All right. You're going to the 70s now. So I'm done with the 60s. So and you have 1 there. I don't like this data because all over the place, you have a search for them in ascending order, but everybody will get the same thing to do. So you're going to do the 70 first. The lowest one is 70 right here. So let me circle it as I use it, right? So you're going to put a 0 for the 70. Pen wants to calibrate. Pen wants to calibrate. 70. So you put a 0 for the 70. The next lowest value is a 71. So a 71 right here. That's a 71. So you put a 1 for the 71. The next lowest value is 75. No, 74. So a 74 right here. So put a 4 for the 74. You have 75. That's a 75 right there. So put a 5 here for the 75. Then you have a 76. That's 6 for the 76. Then you have 70 or 78 right here. 78. So put an 8 for the 78. Then you have a 79. You have 2 79s. 1, 2. So you're gonna put 9 and 9 for the 79s. Oh, you have another one up here. Thanks. 79 again. Good. Another one up here. 79. I don't like how to give it the state, so that's how it is. 79. All right, looking for the numbers with the 80s now. The 80s now. So looking for the numbers we start with 8 now. All right. So I see 1 right here. Use a different color for the 8s. So I have 1 right here. I have 1 right here. And as you find them, you have to put them in ascending order. I have 1 and 2 right here. I have 1 up here. So all right. So those are the numbers in the 80s. So lowest one is this 80 right here. Lowest one is this 80. I put a 0 for the 80. Then 81. 81. Then the next one is 83. 83. So put a 3 for the 83. Next one is 84. So put a 4 for the 84. Then you have 86. So put a 6 for the 86. Look for the numbers in the 90s now. Smart those again. Numbers in the 90s. All right. So 1 year. So 1 year. You have 2, 3 of them in this line. You have 1 here. I have 1 here. Again, you have to put them in ascending order, guys. All right. So looking at them, the lowest one is this 90. Put a 0 for the 90. And there are how many 92s I'm seeing? I'm seeing 3 92s. 1, 2, 3. 3 92s. So that's 2, 2, 2. 3 92s. And I see a 94, which is this one, 94. So I put a 4 for the 94. And then a 95. So I put a 5 for the 95. You're going into the hundreds now. A 99 there? Oh my, me blind. Where is it? Did I pick it? Mark it? Oh yeah, I'll be here. So all right, good. 99. I mark. I would have found the eventual sick. I'm going to count to me done. Make sure I have 35 values. So 99. So I would have found it. No worries. All right. So now we're going for the tens now. 1 0. All right. So 1 year. So 1. All right. Where are we? 103. I would say we have 108 and 108, right? 2 of them, right? So put 8 and 8. Then we have 109. 2 of them. 1, 2. So it's 9 and 9. Good. So we have the 11th now. And there are 1, 2, 3, 4 of them. What's the lowest one? 1, 1, 1. 1, 1, 1. Then you have, that's 1, 1, 1. They have 1, 5 right here. They have 1, 1, 6 right here. So put a 6. And they have 1, 1, 8. That 8 right here. But one important thing when you finish, right? When you finish a boxer, when you finish a stem and leaf diagram, guys, you must put a key. You must put a key to explain it. You must add a key to it. You're going to put the key over here. And the key is like this. You're going to give an example. I can give 2 examples. Because them have double digits and this, I'm going to give 2 examples. Give an example of a single digit. Give an example of double digits. I'm going to say, okay, so for example, 7-1 in 71. So you put 7, 7 line, me 71. Say that. And then you can put 10, 8 means 108. 10-8 means 108. I have done 3 months ago for that in 6 wicked. Sometimes I'm wicked and sometimes I just feel like it was too kind of tedious to search for the values. That's what I think. You answer me, but it is what it is. You gotta get the same thing to do. So you know, like you alone get that. That those things they could have been a little bit more friendly with searching for the values. You get me? Rather than you have to search out it. They could have given the value in a sending order for you or give less values. But did we account for all the values? Think we account for all the values? You can add up these and make sure, you know. Make sure we account for all the values. So this line has what? 5 values. This line has 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Add them up for me as we go. This has 9 values. Then 1, 2, 3, 4, 5 values here again. 5 plus 19. Then 1, 2, 3, 4, 5, 6, 7 there. 7 values. Add them up for me. Much out of is that 6? So something wrong there. 5. Oh, all right, cool. That check. Thank God. The data is more here. That's one of the advantage of the stem and leaf. The data is compact. These values are not repeated. Because look, if you were to write out everything, you'd have repeated this 5 times on this line. How many are there? So 9, you have repeated this 7 9 times, and so on. So the values are not repeated. You can also have an idea of which range of values, like you know that the 70s have more than 90, than the 90s and so on. So you can see, you can kind of get an idea of the spread of the data in a sense, right? And it's in ascending order. Right? So those are some of the advantages of the stem and leaf diagram. It says, from the stem and leaf diagram, determine the value of the median. So the median is the value in the middle. Now, there are 35 values, and when there's an odd number of values, the one in the middle is the median. Now, if you have 35 values, and you take out the 34, and you split that half and half, you get 17 and 17. So the 18th value is the median, because you must have the same number of values below the median as there are above the median. But if you don't remember that, you can remember this little thing, how you find the position of the median. And this is it. The position of median is Q2. The median is the second point. So, pick up the case. Let's just shape data. I cannot bother now. You can select that. All right. So we can go for the position of the median. If you don't remember, you can do this. The position of Q2 is half of the n plus 1 term. Portion of Q1 is a quarter of the n plus 1 term. Portion of Q3 is 3/4 of the n plus 1/3. That's half of the n plus 1/3. Now n equals how much? N equals 35, don't it? So it becomes half of 36, which is what? The 18th term. That's what we just said, don't it? So the 18th term is Q2. So this tells you which term is the term. So you're going to look for the 18th term now. All right? So you can find the 18th term by counting up here until you find the 18th term. But we can divide up this data. What you said? 17 and 17. So you can divide the bottom half and the top half. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the top half. That's the bottom half, you know. So these figures down here is the bottom half of the data. These. That's the bottom half of the data. And the top half of the data, therefore, is up here. So the one after this. This is the 18th value. Right? Yes, sir. That's right. Let me just see. We have 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. No, that's not right. Something is wrong. Let's go back. I want the 17th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, that's 14. 15, 16, 17. So this is the Q. This is actually the Q1. The Q1. The Q2, sorry. That 4, that 84. Let me go again. So this is the Q, this is the Q2. So it means that this is the bottom half of the data up here. So that is the bottom half of the data. And then this is the top half of the data. So you must have the same number of values in the bottom half and the same number of values in the top half. I can divide the data half and half. So you're supposed to have 17 values down here. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Good. So that value that I've circled in the middle, the 4, which is actually 84. Not 4 is actually 84. So the median is 84, the 18th value. But if you answer that, but I said that, that will be the 18th value if you found them. So that value is the median. So we said it is the portion of Q2 is that the 18th value. So the median Q2 is 84. I want to look at the data. Note I did not put 4, I put 84. That 4 right here is 84. What are these measures in again? Centimeters. So you have to give the value, you have to give the answer the same value of the data. So it's 84 centimeters. That's it. Then we want the lower quarter. That is Q1. So similar kind of calculation. Position of Q1 is 1/4 of the n plus 1 term. So it's 1/4 of 36, which is what? The 9th term? Huh? The 9th term? Something wrong with that. So, because the much volume have them, but oh yeah, it's right. I have 17 values in the bottom half. So the 9th term. It's right. So let me show you now the concept, why I was saying it right. So the portion of Q1 now is like you're going for the median of the bottom half of the data. The bottom half of the data is down here, so that's set of value down here, so that I've served. That's the bottom half of the data. And that's the top half of the data. So like you want the median of the bottom half. Now there are 17 values in there. The median of 17 values is the 9th value. And like remember I say 17 values, they took out the median, they have a 16 left, right? Half and half of 16 is 8 and 8. So the value after the first 8 value is the median. I have 8 value on the bottom half, then you have the median, and you have 8 values on the top half. So the 9th value. So you're counting looking for the 9th value now, which is the Q1. Hold on. Let me just do this first. 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th value. That is the Q1. This value. Middle of the bottom. So you have 1, 2, 3, 4, 5, 6, 7, 8 values below it. 1, 2, 3, 4, 5, 6, 7, 8 values above it in the bottom half. And we can just find the upper quarter at the same time. That's going to be the 9 value up here so as well. Mid of the top half. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So like it's this value. 1, 2, 3, 4, 5, 6, somewhere. I want the 9th value, right? Or 9th value from the back. 1, 2, 3, 4, 5, 6, 7, 8, 9. Huh? 1, 2, 3, 4, 5, 6, 7, 8, 9. This value. 1, 2, 3, 4, 5, 6, 7. Something wrong. Something wrong. That's supposed to be the middle of the top half as well. No, it's not going to be the 9th value up there. Not going to be the 9th value up there. Huh? Hold on. So, say that again. Hold on. It's supposed to have the same distribution as up here. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. The 9th value. So you have 8 values. And then you have 1, 2, 3, 4, 5, 6, 7, 8. It's supposed to have the same thing. 8 values and then the 9. Oh, it's 8 values and then the 9 values. So it's supposed to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if you have 17 values, so it's the 9th value. So why am I not getting it right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, this one. That is it. 1, 2, 3, 4, 5, 6, 7, 8. Oh, the 9th one is this. Okay, that is it. It's correct. So that is the upper quarter. This is the upper quarter, middle of the top half. All right. Sorry, I'm toiling over it. So anyway, so Q1, but Q1 is a lower quarter. So the Q1 is a 9th value, which is this value right here, which is actually 75. 75. So its Q1 is 75 centimeters. Then here another one, the upper quarter. So you see we actually have it, which is Q3. So in this case, the position of Q3 is 3/4 of the n plus 1 term. So we need to remember this thing that I'm writing for the position of the quartiles. So you can count and find them. But we know the middle of the top half anyway, same difference. So it becomes 3/4 of 36, which is what, 27? So 27 term. 27th term. And it's going to be this value. It's a 27th term. 27, 28, 29, 30, 31, 32, 33, 34, 35. That's 103. It's 103. So Q3 is 103 centimeters. That is it. All right. Then they're going to want a box and whisker plot, I'm sure. No? It says, at another nearby nursery, the height of the children in the same age are recorded. The median height is 79 centimeters and the interquartile range is 24. It says, compare the characteristics of the two groups of children at the two nurseries and describe one distinct observation about the distribution. All right. So I guess they want us to maybe they want us to do like a box and whisker plot, a box and whisker sketch to see the skewness of the two of them, so we can compare them. Right? It says at another nursery, the height of the children is the same, of the same age group recorded. The median height is 79 and the interquartile range is 24. All right, so the interquartile range, this interquartile range is Q3 minus Q1. Q3, this is Q3 minus Q1. That's what it is. Q3 minus Q1 is 24 centimeters. But up here, the interquartile range up here, which is Q3 minus Q1, works out to be 103 minus what was Q1 again? 75. Somebody works out for me, please. 103 minus 75. So 100 minus 25 is 25, 28, right? 28. 28 centimeters. And this median is 84. 84. All right, so down here we have Q2 is 84 and the interquartile range is 28 centimeters. And at the other place, Q2 is 79 and the interquartile range is 24. All right, it says compare the characteristics of the two groups of children at the two nurses and describe one distinct observation about the distribution. All right, let me see if I can figure out what's that. All right. So this one has a wider interquartile range. All right. That one has a wider interquartile range than this one. But this median is higher than this one. How do I interpret that? Compare the characteristics. How does this color say what you see? I just compare what we see. So the interquartile range is how wide it is in the middle. So in the middle, if you were to draw the box, that is wider than this one, and the interquartile range. That's the interquartile range will be this width, 28. So if you overlay them, all right. So I would say for the first one, the values are more widely spread from the median because the interquartile range is 84 compared to the interquartile range is 28, sorry, compared to 24. So I would say this one, the values are more widely spread in this one, right? Because the wider spread interquartile range. Q3 minus Q1 is a more widely spread, right? And the median of this one is 84. That has a higher median than this one. I don't know what think about this and see what kind of interpretation I would want. I come back to this one. I don't know what specific interpretation I want, but I would just basically state that this one has a wider spread. So this one is more widely spread. So the first one is more widely spread. That's the first nursery. First nursery is more widely spread because have a wider standard, wider interquartile range. So this one is more widely spread. Widely spread. And this one is less widely spread. But this one would have a smaller spread. Q3 minus Q1 is just 24. It's just 24. That's Q3 to Q1 is just 24 centimeters. While up here, Q3 to Q1 is all of 28. One is 28. Right, and the median is in the middle. I don't know if I need to put the two of them on the same graph. Oh, I want to come back to this one because I don't know specifically what explanation they want, rather than just stating what is there, which is the key thing is that one is more widely spread than this one, right? Because the spread of the interquartile range for this one is 28, while this one is 24. Right? So right around the median, the what is the height again? The height of the students for the first group is more widely spread than this one. It have a higher a higher interquartile range. So the valley is more widely spread. All right. One is median is 84, one median is 70. It's hard to know without other pieces of data. All right. That's all I would say. More widely spread in the first one. All right. I can't say this one is more closely spread. I could say this one is more closely spread. That one is more close spread. That's what I would write down here. Second one is more closely spread from the median, and over here is more widely spread from the median. All right. For that one has a higher median than the next. It don't help you. It don't help you really. Okay, I don't know the actual values of the next group. You get me? You don't know the actual values of the next group, you know. So the median alone can't really say much. Can't tell you much. There's a higher median and it's more widely spread. That's all I would say. And the median is just the median is just the height of the median is just the height of the student in the middle of the distribution. That's in ascending order. That's all. Right? Because if you don't know that, you don't know the values of these, you can't say much about it. You have to know the actual values. Right? So that's what I would say. First one, the values are more widely spread around their median compared to the second one. I could say the second one because of a lower interquartile range, Q3 minus Q1, I would say it is less widely spread, or I can say it's more closely spread. More closely spread. Right? Because the values are closer. But the interquartile range is just 24 compared to 28. That's all. That's all I could say. More widely spread, more closely spread. Want to get that? All right. So I don't want to say probability. So we'll leave this until we cover this stuff. All right. We'll leave this until we cover this topic. All right, let's go to 2020. Let's go to 2020. 2020. 2023. So if I come upon one that is similar to what we do already, I'm going to allow you guys to do it. All right? I'll allow you guys to do it. I come upon one that's similar. All right, let's look at this one. 2023. 2023. All right. So one here, this one says, the following stem and leaf diagram represents the scores out of 80 students. Oh, the scores out of 80. Oh, okay. Scores out of 80. Scores out of 80 of students in an ADMATS exam. Okay. The score that they get out of 80. So these are the scores. And then this one don't give you any key, interestingly, but they should give you a key. So for example, this 3 years, so mean that them score 33 out of 80. All right, that's what it means. And this 3 right here, or the 6 right here would mean 56. All right, even though they don't give any key, that's what it would mean. It says, write the raw data set that was used to construct this diagram. So basically, just want to write them out. So you're going to write the 30, you can just write them out. You just write them out in ascending order. Just 2 marks, so let's write this out. Interesting. So it's 30, 33, 37 on the first line. What is that? Good. And I can list them under here now. Them say write them out. I don't have to write them with this way. I can list them out under here if I want. So I'm putting the 40s now. So it's 42, 44, 42, 44, 46, 47, 49. Next one, 51, 53, 53, 56. Next one, 60, 67, 67. Next one, 71, 79. What is that? Understand that? Just list them out. I don't know the purpose of that. But anyway, determine the following measures for the data. The median exam score, the median. Someone can do that for me. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if there are 17 values, then one of them is the median, one in the middle. So the 17 value, to take out the median, you have 16 left, divided by 2, you have 8 and 8. So you have 8 below the median and 8 above the median. So the median has to be the 9th value. See that? So come, work out and tell which one it is. Or you can calculate it. The position of the median is half of the n plus 1/3. Half of 17 plus 1. 17, we say it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes. Which one again? Huh? Which one? 51? You said 8 and 8, right? So put the body like this. Put work with these down here as well if you want it. But let us do it on this. 8 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's the bottom half. That's the bottom half. That's top half. 1, 2, 3, 4, 5, 6, 7, 8. Right. So the median is this value right here. The different color. That's Q2, right? Q2 is 51. So it's a 51, right? And if you want to calculate, you put a half of the n plus 1 term as a position of it, position of Q2, which is half of, how much I get? Half of 18, which is the 9th term. We calculate as well. So Q2, what you say it is 51, right? What is the data here? You must always look what the data is here. Or scores, 51 scores, 51 marks. So it's 51 marks. The next question, the mean score. Come, work out the mean score for me. Calculate the mean the same way. Add them up and divide by the number of values. So you calculate. Add them up and divide by the number of values. The formula for mean, x bar is the sum of the values divided by the number of values. So we're going to add up all those values and divide by them. So here we can write the sum of the values. Sum of the values equal the number of values equal 17. What's the sum of those values? What am I up to? Add up all of these. Huh? 885? 885. Anybody get that though? 885. Okay, so the mean down here is 885 divided by 17. What do you get for that? Huh? 52.05? 0.05. That's it. 52.05. All right, next one. The modal score. What's the mode? What is the mode? The mode is the value that occurs most frequently, right? You can see it up here in the table, in the box, in the arm. You can see it in the stem and leaf diagram. It's like it has two modes. It has two modes. Or call a bimodal data. It has two modes. Yeah. See, it's two modes have, right? That and that, don't it? So the mode is 53 and 67. It's bimodal. All right. See modal scores. So it's 53 and 53 marks. And it's supposed to be marks, yeah? Marks. Give the data and the unit of measure, which is marks. So 53 marks. And next one is the most 67, 67. So let me have 53 and 67. 67. All right, what else I want? All right, I've said, given that the setup for the set of data, the sum of x squared is this, and the sum of x is this, which we got it. We got it. This calculation was correct. They're just telling us now, but we have to work it out. So let's give us this now. Western Wicked. Find the standard deviation, and this is the form of a standard deviation, guys. Simply put, we don't need a sigma. We can just, and this is the sum of x squared over n. That's the formula they give us. And they put that over n minus 1. So this is just a different way of finding it. They want a standard deviation. That's the formula they gave us. Just put the values in there and work it out. If you don't give it on the formula sheet, it's on the formula sheet. There's another formula other than this on the formula sheet as well. Oh yeah. Oh, I don't see it there. You don't know, so this is it as well. You have this as well. We're gonna square root because this s squared is what we call variance. When you square root the variance, you get the standard deviation. Right? I have to explain in the video that I told you to watch. That's one formula. That's yet another formula. But they gave us a formula that I want to use. Right? Because you have a standard deviation for sample and a standard deviation for population. So that's a slight difference. So they give you the formula to use, you use it. So what do we need? They give us the sum of x squared, which is this. So this value come in here, so. And they give us the sum of x. That value come in here, so. And the n is how much again? N was what? 17? N was 17, right? So have everything where you need. Just put the program in the formula. N is equal to 17. So that standard deviation becomes equal to the square root. It's a free question, you know, of this figure coming here. Sum of x squared is 48999 minus the sum of x and you square it. That's 885 squared over 17 all over n minus 1. 17 minus 1. Put all that in the calculator and work it out. So it's a 3 marks question. Okay, let's put that in the calculator and you work it out. The square root, no, not that, square root fraction. On top we have 48999 minus fraction again. That's 885 squared over 17 all over 17 minus 1. I'm getting, if you're putting everything right in. All right. So we're getting 1595. That's right. Together kind of beat. What is data? That figure looks big. standard deviation look big. Over cube. Oh, I don't have a square plate, over cube. See, something look foolish there, but don't accept it, you know. So it's 13.5. I have a cube on the 885, that's what I call that. So it's 13.5 marks, the standard deviation. Everything I calculate is the unit of measure, which is marks. Right? I give 4 marks for that, you know, for the problem figures in that formula. Can you imagine that? Yeah. Yeah. Put the what? Yeah, you can put the unit on the key, yeah. If you right, well, the safe thing to do is to put it, even though they gave us one and they didn't put it, but I think that's an oversight. But just put it. Just put it and put the unit on it as well. Right? Put the unit as it as well. So let me see when they put the unit on right. First one. No, I didn't do the first one. When you put it on the key, yeah, put it on the key. This one don't say if a student needed to score at least half the total marks possible to pass the exam, determine the probability of a student failing the exam. Give your answer to 2 decimal places. All right. So if a student needed to score at least half the total marks. So what's half the total marks? The total marks is 80, right? So you want a student who score 40 or more. So half the total mark is 40. So at least 40 means it needs to score greater than or equal to 40 marks to pass. Therefore, it needs to score less than 40 marks to fail. So you want to know how many students score less than 40 marks. I put that total number of students, and that's probability. See? It said if a student needs to score at least half the total marks, which is 40, possible to pass, determine the probability of a student failing the exam. So this is how you fail the exam, by getting less than 40 marks. So you need to know how many students got less than 40 and put that over 70. Right? So you're looking for the scores that are less than 40. How many scores are less than 40? Just step 3 here. See that? So it's 3 over 70. Right? 3 over 70. Right? So you can say number that is less than 40 marks equals 3. Therefore, the probability of scoring less than 40 marks is 3 over 70. And I want that decimal to 2 decimal places. So it's 3 over 70 we want, which is 0.176. 0.1765. 2 decimal places, it becomes 0.18. 0.18 to the probability. Probability to have a unit, right? But that's something divided by something. A unit divided by the same unit. So student divided by 2. But go to that. All right. At the next part is thing there. Given that a randomly selected student has passed the exam, what is the probability that the student scored? So it's a probability. I don't really want to get into this. Because it's not a conditional probability. This part of it is a conditional probability. I don't want to get into this part of it. So we will come back to this question. See, so the second part of the question is probability. So they have segued from the statistics and have gone into probability down here. But I don't want to down here, so part C is probability. But we don't cover that yet. We don't want to, because this question is what we call a conditional probability. Given that a random selected student has passed exam, so now you're now picking out of the ones who passed. Right? So out of the ones who passed, which is 14 passed, right? It says, given that a student selected at random has passed exam. So you want out of the ones who passed, you want to know the ones who got a score over 60. So the ones who passed were 14 of them, right? And you need to know how many of that 14 got over 60. That's what this is asking. It's a conditional probability, but we're not doing it because we don't have the probability. Right? We have the probability next week. Right? So we come back to this. And let's look at 2023. It's a conditional probability. All right, guys, your time to work. No. Most see a question that you can do now. Most. Here you go. Your time. So part A is probability. A, B, and C. All right, come down here, so now. The following table shows the marks obtained by 27 students in a math test. All right. Construct a stem and leaf diagram. Come, guys, do this for me. Stem and leaf diagram. Put our time up on the screen. So you've got a stem and leaf diagram. See, it's one advantage of using a stem and leaf diagram to display the data. Then down here it says state the range of values. State the range of values of the marks obtained by the students. It said the data are displayed on the following box and whisker plot. State two distinct observations. State two distinct observations that has about the data as seen in the box and whisker plot. And then the question though. Come do this for me. They give us a box and whisker plot. So do this time leaves for me. Much minutes you want for that? 5 minutes? No more than 5 minutes for that. 5 minutes. Stem and leaf diagram. Quickly. Good thing about this one is already in ascending order for you. So nice. So see if you learn from the one that they gave us that was not in ascending order. This one is already in ascending order. So stem and leaf diagram, pick and fast. 4 marks for that. Stem and leaf diagram. Oh, sorry. Yeah. No, five straight. And first, we'll get it to we'll get it now today. Come guys, 2.5 minutes. All right, guys. Ready? Not ready yet. Oh, man, so this the one diagram in the job because of my so this is the put at time and I put some figures on one chart, man. So I was transferring the figures from a table to a chart. The tens upon the left side and the ones upon the right side. I put it, and they are already in ascending order. So this is easy. Ready now? Let's go. Stem and leaf. The values are already in ascending order. That kind of make it kind of easy. So you have numbers in the 30s and they go all the way up to the 90s, right? So it's 3, 4, 5, 6, 7, 8, 9. The 30s now. So it's 30, 35, 39. So it's 30, 35, 39. The 40s now. 42, 45, 45. 42, 45, 45. 50s. 52 and 59. 52, 59. 52, 59. Next one. 61, 61, 65, 69. 61, 61, 65, 69. 70s. 70s, no. 70, 71, 75, 77. So 70, 71, 75, 77, 79. Those are the 70s. And the 80s now. It's 81, 83 two times. 81, 83, 83, 85, 87, 89, 85, 87, 89. And the 90s now. So it's 90, 90, 95, 98. 1990, 95, 98. And basically that is it. All right? Simple as that. That's everybody should get. And you put in a key. And the key is like 4 line 2 means 42. 4 line 2 means 42. And this your marks obtained at this. If you want to put marks on this, it should be safe. You put 42 marks. 4 marks for doing that. Next one. State one advantage of using the stem and leaf diagram to display the data. What are you gonna say? What you could say? One advantage of using the stem and leaf. Yeah, it put data more compact, the more compact way of representing the data, and the stem values are not repeated. Huh? It's just how it presented instead. But I said the data is more compact, right? Yeah, easy to read, and the stem values are not repeated. So I just say let's write it, right? So the data is presented in a more compact format with without repeating the stem values. That's it. Right? Could divide it into two observations to could say the data is more compact. You have the two, I say the same way. The data is more compact, one, two, stem values are not repeated. You understand? But go to that. This one now, do this one for me now. This one give you this question. It says state the range of values of the marks obtained by the students. 1 mark for that, that's easy. So the range is of the largest value minus the smallest value. This minus this. Good? Right? Largest minus smallest. But answer this part for me now. It says also the data is displayed on a box and whisker plot. State two distinct observations about the data as seen in the box and whisker plot. Two observations as seen in the box and whisker plot. What are two observations they make from the box and whisker plot? Two observations. Come on, man, what the box and whisker plot show? Show the quartiles. So let me know, these are the quartiles. So that's showing the quartiles. It will tell you that the first quartile is 52, the median is 71, and upper quartile is 85. Okay? That's one thing it shows. So it shows a quartile. It also shows skewness. This data is left skewed or right skewed? Negative skewed, yes. But the box and the whisker on the left, longer. Both of them longer. So the left side is longer than the right side on the median. See it? So this one is the left skewed or negative skewed. So that's two good observations. You know what the median is from it. You know the interquartile range. But looking at it, you can see the median. You can see what the median is. Was 71 one of the values in the data? Yes, 71 was a value in the data. But at least you can see it on the box and whisker plot. The median is 71 and the data is negative skewed. So that's two observations I would write. So you could say, by the way, what the range of pressure is what? 98. It is 98 minus 30, right? Which is what? 68 marks is the range. And down here you can say 1. The median is 71 marks. And 2, the data is negative skewed, negatively skewed, negatively skewed. That's it. All right, that's 2022. Come, let's go to 2023. But have that. All right, let's go to 2023. You're gonna do it, Emily. You're gonna do it. 2023. No, 2021. 2021. We're going backwards. 2021. Let's go. All right, so this one give a stem and leaf diagram, but I show it vertical. The stem and leaf but I'm sure vertical. That's all. Right? So instead of reading it from left to right, instead of reading it from left to right, as it normally is, you have to read this one from bottom up this way. See that? We can still see the quarters and everything. Right? So you still see the lowest value right here. This is Q1. This is Q2. This is Q3. This is the largest value. So you can still see them. So this question is asking you from the box and whisker plot, what is the median? Let me write them all for you. What is the range and the semi-interquartile range? Come, do them for me. So see if the one, the median, range, semi-interquartile range. Those three things I want. Let me see what else I want. Median, range, semi-interquartile. It says comment on the shape. Comment on the shape. I wanted to comment on the shape as well. Come answer these four questions. Let's see what else I want. Comment on the shape. A student determined that the mean score. A student want to determine the mean score. All right. So let's do that part first. Answer these first for me quickly from that diagram. The median, the range, and interquartile range. Come on, I don't need more than 2 minutes for that. But everything is done there. Let's look at the scale and graph properly. Just start reading it from bottom up instead of from left to right this time. Gotta put it vertical. I'm gonna put up by the clock. Let's put up by the clock. Come now on more than 3 minutes for this. Quickly, median, range, semi-interquartile range, and then comment on the shape. Comment on the shape. That's what it means. Comment on the shape. What about the shape? Is it positive skewed, less skewed? Is it positive skewed or negative skewed? Just imagine if it was horizontal, right? Just think of it. Think of how it would look if it was horizontal. Like you take this and turn it around this way. Turn it down so I make it stay. So think of it that way instead. So let me write this up. Questions I must find the median, the range, the semi-interquartile range, and comment on the shape. From 2 minutes, 2 minutes. Huh? No, I'm not going to do the length. The smaller, the first value on the box, the lowest value on the box is Q1. Just imagine that this was turned this way. Just how they give it to you vertical. So instead of reading it from left to right and horizontal, you know, reading it from bottom up. Understand? That is all. Coming up, 41 seconds left. I remember the semi-interquartile range I want, the semi-interquartile range. I'm up, you know. No finish? No finish? Huh? Huh? All right, 3 more minutes. Come on, man. That takes too long. Shape, comment on the shape. Semi-interquartile range. SIQR, semi-interquartile range. The semi-interquartile range is half of the interquartile range. Semi-in maths means half, like semicircle means half of a circle. Semi-interquartile range is half of the interquartile. Finish now. I'm talk, man. So no finish, man. We're going to the second part. All right, ready. Pick and part. And then I'll give you the next part. So the median is just this value. So see here, this value is Q1 right here. So that's Q1. All right. This is the lowest value, you know. This is the lowest value, the 4. This 4 is the lowest value. This is the lowest value on the data. All right. And this is the highest value in the data, highest value. Oh, this is Q1 right here. This right here is Q1. This is Q1. So Q1, that is what? That is 7. This is the median right here, sir. This is Q2, the median. This is Q2. Q2, that is 11. That is the median. And this is Q3 right here. Come on. That is Q3 at 17. Now, what does it represent again? Marks again. I like to set marks in, man. 30 students in a maths test. The scores that they got, right? So they want the median. So the median is clearly this value, right? So based on that, the median is 11 marks. Median is 11 marks, Q2. Q2 is 11 marks. Then they want the range. The range is the largest value, man. It's the smallest value. So the range is 20 minus 4. 16 marks. Then I want the semi-interquartile range. Semi-interquartile range, SIQR, is half of the interquartile range. But interquartile range now is Q3 minus Q1. So that's what we're working on. So it's half of Q3 was what again? 17 minus 7, right? Half of 17 minus 7. 70 minus 7 is 10. Half of 10 is 5. 5 marks. All right. Comment on the shape. So if this was horizontal, that tall box would have been to the right, don't it? So that the two whiskers are the same length, you know. So the box will determine the skewness. You see that? So it is right skewed or positive skewed. It's positively skewed. Because if it was turned horizontally, the long box, this box would have been to the right of the shorter box. Look where the longer box is. So if the longer box is to the right, it is positive skewed. If the longer box is to the left, then it is negative skewed. So you're looking for the box or the whisker. The box or the whisker. If them kind of, huh? I mean clockwise. Now I'm saying if normally it is given horizontally like that, but they give it vertical this time. You see that? Huh? They're not going to turn it the other way because the data usually increase from left to right or from horizontal, from vertically. You understand me? It's like a graph, you know. It's like a line graph, really, you know. Boston always applies like a line graph, you know. And values, data usually increase from left to right if it's horizontal or upwards if it's vertical. So it's gonna give you. In fact, this was the only time they gave a vertical one. All the other times the horizontal one they give. Huh? Positive. Because positively skewed. I can say right skewed. So it's skewed to the right. Because the box on the right, long box, is skewed to the right. SKEWED. Okay, positively skewed. So when I ask about the comment, it's always about skewness, yeah? So it is positively skewed. See there? See on the screen there? Positively skewed. I'll answer this question someone. It says, a student wants to determine the mean. It says, state one reason why it would be impossible to determine the mean score from the box plot. Why is it impossible to determine the mean score from this box plot? Why? Because what? Because I don't have the values to add up. You don't know the actual values are. It's only showing the lower value, the high value, and showing the quartiles. But the quartiles might not even be any of the actual values. You see me? In order for you to calculate the mean, you have to have all the values, the actual values, right? That is it. The actual values are not known. So the actual data values are not shown on the box plot. Next one. State what additional piece of information would be needed to determine the mean. You need to know the actual scores, right? That's all. Right? So the actual scores or the actual data values. I need to be able to add them up and divide by the number of ones. You understand? So you can't add up your own. Right? That's it. Next part. It says, given that the sum of the 30 scores is this, and the sum of the square of the scores is this, determine the standard deviation. So you're going to use the formula for standard deviation. So this is the sum of the scores they just gave us. So when I give you the sum of the scores, it's for you to be able to find the mean. Right? But this is the formula for standard deviation. I'm going to show you now. No, this one it can be different. This is what they're giving us. It can be different. So it can be this, or it can be this. Now, see this F business, they don't really need this F. And what you have to know is that the sum of F is just the number of values. And this is for variance. The S squared is for variance. Standard deviation is where you square this. So you take out the square of this and square these. So you can either use this one, which you're doing the values minus the mean, and then you square that, but that is more work. This is the easier formula to use, this one. So if I were to write this formula in a more simple way, then the standard deviation would be the square root of this, the sum of x squared over n, this is over n, minus the mean square. The mean square. Understand? The better we work it like this, use this formula down here. So it's easier. So copy this and use that down on the question. All right, so when I use this formula down here, so all right, so we need the mean. So the mean, this mean value right here, the mean is equal to the sum of the scores by the number of scores. But the sum of the scores is this. So it becomes 354 over 30. Now let's me this as a decimal. 11.8 exact? 11.8. So that's right, that's 11.8. So the mean is 11.8. And they tell you that the sum of the squares, which is this, that's what they just gave us now. The sum of the squares is 4994. So you put those values over here, so now. So the standard deviation becomes the square root. The sum of the scores squared is 4994, where the number of scores is 30, minus the mean, which is 11.8 squared. Put that in the calculator. Tell me what I get. What I get for that? Huh? 5.21? Huh? 5.217? 5.217. Three significant will be 5.22. 5.22 marks. So it means that the marks spread from the mean by about 5.22 marks. What that means? So on average, what they're saying that the scores spread from the mean score by about 5.22 marks on average. That's a standard deviation. Understand? It's a measure of spread from the mean right here. So all the values generally spread away from the mean at 5.2. That done. Let's look at 2020, 2019. 2019 was the paper before this one. 2019. Come, I'm not doing this one for me now. Oh, probability. Hey, man, if you want to watch a video here, and in particular, watch the I saw on two sides. I'm going to one different. So on two sides, go on different. Can do this one some other time. Let's go on 28. Here you go. I'm gonna tell you one more. So the first part I want to determine the median. It said the number of runs scored by a cricketer for 18 consecutive innings, that's 18 times. Number of runs scored illustrated in the stem and leaf below, right? I'm gonna give a key. So 0, 6 means six scores. Six. So these are run scores. And 18 values here, consider 18. But determine the median, determine the interquartile range, and in the space provided to a box and whisker plot and comment. All right. So for all of this, make a note up here. For this data, I'll do this for me now. See it here, you're doing the median, you're doing the interquartile range, part two, you're doing the interquartile range, part three, you're doing the box plot, and comment on the shape. The box plot and comment on the shape. See it here, guys, do this for me. We're going to some time. Not that. Not that, not that. Not that. What am I looking for? I'm looking for the clock. So I can give you a, what means you want for this? 10 minutes? 8 minutes? 8 minutes. I need 8 minutes for this still enough. But anyway, go on. See there? For that stem and leaf diagram, for the runs for the, by 18 innings by a cricketer, determine the median, determine the interquartile range, and draw the box plot and comment on the box plot. Remember, the box plot is a scale drawing. That's a bit to scale. So we do a kind of scale drawing. So go on, do that for me. Finish. 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 Huh? I'm doing the box back now. All right, let's do it then. I'm gonna do it though. I'm gonna do it drive. All right, I'm gonna do this one and then I'll do the next one. Cause it's something easy. All right, it's very like you do a line graph. A box plot like a line graph. Let's go. No problem. Let's go. All right, how many values here? 18 values, right? So there are 18 values. Initially, I'm going to divide 9 and 9, right? 9 and 9. So when there are even number of values, the median becomes the average of the two middle ones. Two middle ones going to become the 9th one and the 10th one, don't it? Because 9 and 9, so the two middle ones going to be the 9th one, the last one in the first set, and the first one in the last set in the second round, right? If you want, you can calculate the position of Q2. So the position of Q2, see here, the position of Q2 is half of the n plus 1 term. Remember, half of the n plus 1 term. Those who did C-Sec last year are supposed to remember this, right? And n is 18, right? So this becomes half of 19. Half of 19 is how much? 9.5. That's the 9.5 term. Now, the 9.5 term means the average of the 9th and the 10th term. That's what it means, right? If you calculate the 9.5 term, it means that you calculate the average of the 9th and the 10th term. So this is equal to the 9th plus the 10th divided by 2. That is what's going to give you the median. So Q2 is going to be equal to that. So therefore, Q2, you're going to count the 9th term. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 9th term. This is the 10th term. See that? So you're averaging those two values. So this value, remember now, this value is 19. 19. Not 9, it's 19. That's 19 plus. This value is 24. Plus 24, I divide that by 2. Whatever that work out to know is your Q2. And you can remember, you could have divided up the data this way. But I've done it this way as well to find those quartiles, those values. So it's 18 values in all. You divide 9 and 9 first. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the bottom half right here. This is the bottom half. And this is the top half. So these are the two middle values. These two are the two middle values. Because when there's an even number of values, right? All the values will come in the bottom half and the top half. The median is like to make for it to have a median, you need to have an odd number of values. So like you have to add the median to it. So you're adding the median in the middle of the two, in between two middle values, which is the average of the two middle values. So it's the same thing. You have to average these two values to get the median, right? Because those are two middle values. So what is work out to? Huh? 21.5 runs. Remember, these are runs scored, these are runs scored. No, man, that can't be divided by 2. When you get that? Oh, yeah. Sorry. It's not 9 and 4. Sorry. Yeah, so my mistake. So it's 19 and 24. Yeah, you're right. My mistake. They want the interquartile. So to find interquartile, you need to find a Q3 and a Q1. Now, Q1 is the middle of these bottom half values. How many values there again? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's easy. If it's 9 values there, then it's a fifth value. Because that you have the 9 value, take out 1, which is going to be the median. You're going to have 8 values there. You're going to have 4 below the median and 4 above the median. So it's a fifth value. See there, 1, 2, 3, 4, 5. So this is the Q1. That's right there, the Q1. And then same thing up here. So 1, 2, 3, 4, 5. This value. This value is going to be a Q3. So this is Q1, this is Q3, and this value that we found here, so it's Q2. You can find it that way, but you can also calculate it. See here, the position of Q1 is 1/4 of the n plus 1 term. So it becomes 1/4 of 19. 18 and 1, 19. So around there. 1, 2, 3, 4. 1, 2, 3, 4. Where am I getting that? 1/4 of 19. Well, it's report 1/4 of 18. 1/4 of 19 is how much? How much? 4.75. That would normally mean the average of the fourth term, the fifth term. Right? And we're going to see if that's right. So we have 18 value divided 9 and 9. So more the middle of the bottom half. 9 and 9. 1, 2, 3, 4. Just making sure. Because we have 18 values. Let's do a little quick check here. So if we have 18 values total. 18 values. 18 values, right? We divide it with the median. So we have 8 down here, so. Now we have 9 down here, so. 9 values up here, so. And we have 9 values down here, so. So the middle of this one is the fifth value. And then this now is the fifth value from the back. Fifth value this way. So what the calculation that give it, not matching. So it's 1/4 of the n plus 1. So let's say Q3. I'm sticking to that fifth term there. Let's see. Position of Q3, the 3/4 of 19. What is your record? 3/4 of 19 is a 14.25. Yes, this don't work every time. I just want to tell me that is between the fourth, but it is the fifth value. I have 9 values on the bottom half, and the middle of the 9 values is this one. I have 9 values on the top half. Middle of 9 values is this one. So I'm using those. That's 10 and 31. 10 and 31. So based on that, Q1 is equal to 10 and Q3 is equal to 31. So the interquartile range, Q3 minus Q1 becomes 31 minus 10. That's 21 runs. 21 runs. Q3 minus Q1. Middle of the top half, middle of the bottom half. Don't know what the calculation that give it maybe fifth term. 4.75. That's what that's 14th term. That's the 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 value. Anyway, that is it. All right, let's to the box and whisker now. Huh? Huh? Here? No, it's subtract, you have to subtract. It's Q3 minus Q1. Interquartile range is different between the upper quarter and the lower quarter. Huh? This is the values. It's the middle of the top half. The middle of the top half becomes this value. Because look, let me show you. Let me show you. If you have 18 values, right? You have 18 values, right? You divide it 9 and 9. Right? So you divide it 9 and 9. So like you have 18 values and you divide it 9 down and so. And you divide it 9 up at the top. Right? You have to add the median inside the center. You have to add a value for the median. The median is not one of the values. Right? So you're adding the median in between here. Q2. The position, not the value, the position. Right? But this is a good way to do it, you know, you divide the values, you know. So halfway of 9 values is the fifth value. See what I say? Halfway of 9 values is the fifth value. The fifth value is halfway of 9 values. Because like you're trying to find the median of 9 values. The median of 9 values is the fifth value. So you come to the fifth value right here, so the fifth value. And then the same thing up here. So you want halfway is the fifth value from this end. Or is the fifth value from this end too. Same thing. The fifth value from that end. So if you have 18 values and you want the fifth value from that end, then you want the 14th value. Right? So this is the 14th value. I could say this is the 9th value. This is the 9th value. This is the 10th value. That's the 10th value. Right? And you want 5 values from this end. So the 10th, 11th, 12th, 13th, 14th value. The middle of here is the 14th value. The fifth value on this half is the 14th value of the group. So you can sometimes better just break it down like this. Break it half and half. You have 9 values down here, so you want the middle of those 9 values. So you have 4 above, 4 below, and 4 above that value. So this is the median. This is the middle of the bottom half. Same thing up here, so 9 values. So you have 4 above it and 4 below it, below this. So this must be your Q3. This value right here is your Q3. All right? So that's it. So those are the values. Let's do the box and whisker plot. The box and whisker plot is like a line graph, guys. So the value that you need for your box and whisker plot, you need the smallest value, which is 2. That's why I told the value that you need. You need a 2. That's the lowest value. They need Q1. Let me write them out. Let me write out the value that they need for the box and whisker plot. You need the lowest value, you need Q1, you need Q2, you need Q3, and you need the highest value. The lowest value is at 2. The Q1 is a 10. Q3 is at 21. No, sorry. Q3 is at 21. This is Q3. The Q2 is a what again? What do you get for the median again? We got what? 21.5. 21.5. And the largest value, highest value is 47. 47 out here. So these are the values that we put on a box and whisker plot. Those values. First thing you need is a scaled joint. You have to draw us up to scale, like a line graph. So I'm going to draw a line out here, so I'm going to put a scale on it. So I'm going to come down to 2, I'm going up to 45. So you can put like intervals of 5 if you want. So you can maybe go 0, 5, 10, 15, 20, 25, 30, 35, 40. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. I go up to 47. 45, 45, and 15 is a short. 45, 45, 50. That's scale drawing you're doing. So you have to draw something to scale. Right? And then you put in all these values on them and shift this to everything on the screen. Right? You put in those values about the relative position. So first you're gonna put up a mark to 2. If it's a 5, 2 maybe is about right here. So it's a 2.5. So 2 maybe is about right here. So right? So 2, that's a 2. 2. They need 10. 10 is clearly right here. So you put the first box right or so at 10. They need 21.5. So it's a 20 or so. It's about 22.5. So 21.5 maybe is about here. So put a markers again for Q2. They need 21. Upper quartile is 21. Right? So it's 21 was upper quartile we get or 31. I don't know 21. 31 again. I put 21. 31 it was. 31 was upper quartile. It here 31. 31. Huh? You just draw it somewhat to scale. It has to be to scale. So you do a line graph and make sure that the values that spread out evenly. You understand? So you do a sketch, you do it like this. Make the values them relative spread out relatively the same way. You understand? If you want a ruler and make every centimeter be a unit or something like that, well fine. Not every centimeter, every centimeter. Make every centimeter be a unit with a ruler. You get me? It has to be to scale, like a line graph. Right? It is a box and whisker plot is a scaled drawing. You get me? Good. So we need 31 now. So 31 is about right here, so. 31 is about right here, so. That's all, about 31. So put that the other box for Q. For Q. So it's my box here, so now this is my box. That's my box. I'm gonna draw a line down so for this whisker. I need to put in the other whisker at 47. 45 here, so. 45.5 about here. 47 is about right here, so. 47.5. 47 is about here, so. So put the other end of my whisker here and you join it. Before you can put on the values them on it. So right down you saw 2, right you saw 10, right you saw 21.5, right you saw 31, and right you saw 47. Now what that look like? What it look like it's cute? Huh? You see that you see a whisker you well long on the right side. The two boxes them look all the same. And you can actually calculate it. What's the distance between this and this? About 11 that. And this between this and this hour. Almost 11 too. So the two boxes are relatively the same. What is obvious is that this whisker is super long on the right side. It's not just the whisker or the box alone determine students, you know. It's a combination. It's obvious that this whisker is much long. It's very long. What you can do sometimes, if you don't measure from the median and go all the way out, and from this median go all the way out. That length is longer than the length over there, sir. So overall, it is right skewed or positive skewed. You understand me? You understand me? Right? So if you're kind of confused with here, the whisker obviously longer than over here. So the two boxes are around the same. The two boxes are not really significant in terms of how wide they are. The two of them are about the same. But the whisker is super long. They're positive skewed. Positive skewed. So this data is positively skewed. Positively skewed. Based on that long whisker. Put the arrow point and put positively skewed. Data is positively skewed. The data is positively skewed because of the whisker. Right? Sometimes if you do, just measure from the median and go out to the end, so long that is. And from the median go out to this end, so long that is. If the box and if you can't really determine it, they can do that as well. And when you look at it, the right side much longer than the left side overall. See it? But the whisker is obviously longer on the right. Obviously. Two boxes are around the same. So no significant difference in this length over that side. So this is the whisker you got to mix. The whisker is obviously longer on the right. All right? So it's positively skewed. On that done. All right, I'm bring up our next one. 2017. What time is it? Come on, I do one more. I do no box and whisker plot yet. No, we not do one box and whisker plot before you leave. We not come up on the topic here now. Only 2017 paper then. See, here that. I'm falling around. All right, hold on. We'll find it over here, so hold on. All right, come. Do this one, man. Details of this one determine the mean, the mode, the median, interquartile range. That's all. I don't want to do that one. I want to do one after do one box and stuff. Let's see. Hold on. That not asking for the none. That on the basic. Let's go. Want to do a box and whisker plot. Okay, just a line graph, guys. All right, so one here, let me see them give on this one. This one want a stem and leaf. This data is ascending order, so not a problem. All right, now we'll do a stem and leaf for me for this. And I'll do a box and whisker too. For this one. Let me write them out. So now I'll do a stem and leaf. Part 2. State the advantage of using the stem and leaf. Determine the mode. Part 2. State advantage. Part 3. Part 3. The mode. Determine the mode. Part 4. The median and interquartile range. Median. Part 5. Interquartile range. And part 6. Do the box plot for me. Do a box plot. Box and whisker plot. Sometimes there's no spot a box plot. That's it for this question. Do this for me and then we're good to go. Put the time on it. Hold on. About 10 minutes. So, started data, let me tell you what it is. The started data. I don't tell you what the data is for. Come, do that for me. State advantage of the stem and leaf diagram. State advantage of stem and leaf. Of stem and leaf diagram. And then state the mode, find the median, interquartile and do the box plot. Come on. Do the scenario with your meat. So, it's something small. Come on. Internet. Coming up about 7 minutes. East, or the whole paper. Let's just for him. Oh, 4 parts of the whole paper. So you do them over third. You do it? Benefit red. Benefit red. I'm gonna work it out now. I can't wait a couple minutes to work it out. I'm gonna work it out now. See time up. You ready? You ready? All right. State advance, construct the stem and leaf. All right, let me erase these now, understood it. Stem and leaf. What are the stem values? 1 up to 7, right? 1, 2, 3, 4, 5, 6, 7. All right, the ones first. So let me answer. 5, 6, 8, 8. 5, 6, 8, 8. 5, 6, 8, 8. The twos. All right. So we have 0, 0, 1, 2, 2, 0, 1, 2, 2, and then 2, 5, 2, 5, 8. 2, 5, 8. The 3s now, 30s now. So we have 0, 0, 2, 5. 0, 0, 2, 5. Then the 40s now, 0, 1, 0, 1. Then the 50s, 2, 4, 9. 2, 4, 9. Then the 60s, 0, 5, 8. 0, 5, 8. And then now the 75 alone, 75. And you put in a key. And you can say something like 32. Anyone you want to give. 3/2 means 32. Good? Huh? No, there's no unit on the data. Good. Good that you asked for the unit, but there's no unit on this data. Very good. Good that you asked for the unit. But they just a set of data. See? Set of data. They didn't put anything, what is about or anything like that. All right, next part. The one, the advantage, eh? Good. Then the one, the advantage. Same advantage all the time. Data is compact, stem ball is not repeated, right? Data is presented in a compact format with no repeat of the stem values. That's it. Then I want the mode. The mode is the most frequent occurring value. See there? That's 22, 22, 22. Then I want the median. How many scores are there? 1, 2, 3, 4, 5, 6, 7, 8, 24. So if you have 24 values, you're going to divide the 12 and 12, right? So the middle is the 12 and the 13 value. 2 in the middle with the 12 and the 13 value, right? Good. So let's go on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you want to average of these two values. See that? See that? Let's go again. I count again. My mistake. Let's count again. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 and the 13 value. All right. So the median is 30. All right. Good. So the median is 30. 30. All right. Because it's the 12 plus the 13 divided by 2. So it becomes 30 plus 30 divided by 2. All right. Then I want interquartile. So we did the quartiles. All right. So if we have the bottom half and the top half, we can do it. We can do it on the table. We can do it on the box and whisker plot as well. Can do it up here, so too. So we say this was the 12 values first, right? 12, right? And this is the other 12, right? This is the other 12. So on the middle of these 12 values now, the middle of 12, so same thing again. You have 12 values, you divide it 6 and 6, right? 6 and 6. So you have the 6th and the 7th value for the Q1, right? 6 and the 7th value. 1, 2, 3, 4, 5, 6. You do the average of these two. These two giving you Q1, right? And then you go 6 and 6 again. 1, 2, 3, 4, 5, 6. 6 and a 7 value. Going from that way is 1, 2, 3, 4, 5, 6 and a 7 value. So these two, when we circle, will give me Q3. So Q3 are 53 and Q1 are 21.5. You can see that? Halfway between 21 and 22 is 21.5. So Q1 is 21.5. And down at Q3 is clearly 53. But I said that? So the interquartile range then is 53 is Q3 minus Q1, which is equal to 53 minus, what is that, 21.5? 21.5. What that work out to? 53 minus 21.5. How much? Yeah, with that. What again? 21.5 on Q1, man. The average of 21 and 22. 21.5. What is the formula? Where again? Is how many values there? 6.25. So 6.25 can mean the average of the 6th and the 7th value. Which what I did. 1, 2, 3, 4, 5, 6. Even though 6.25 is still average of a 6 and a 7 value. No, it's 6 and a 7 value. So I'm going to prefer to divide it up like I'm doing so. Learn how to divide it up like this. When you have a small number of values. See what I say? Yeah. All right. So donuts, what is the work out now? Huh? 31.5. Yeah, 31.5. Yeah, because it's 3 minus 1.5 and 50 minus 20 here. 31.5. It's interquartile range. Then we're gonna do the box plot. Right? We're gonna do the box plot. So to do the box plot, we need a low value, we need Q1, we need Q2, we need Q3, and we need the highest value. What's the lowest value? Lowest value is 50, highest value is 75. 1575. Q1 is 21.5. Q2 is how much? 30. Q3 is how much? 50, 53. That's what you're drawing. You put drawing that to scale now. Draw a scale, draw a line graph, like a scale line graph and put those values on it. And you're starting at 15. And you can go by 5, you can go by 10. So you can actually start at 10 and going up to 80. Right? So you can go like so. I'm gonna go 10, 20, 30, 40, 50, 60, 70, 80. All right. Let's draw back a line through this and expand this. So let's go like this. Stop like this and delete this. Shift this over. I expand this somewhat. All right. And you're putting on the marks now. So you want 15. That's it. That's the end of one of your whisker. It's 15. Right here, so between 10 and 20 is 15. See there, look at mark this up. Your first box at 21.5. The box start at 21.5. It's at 25. So 21.5 maybe about right here. So you put a box here, so. Next one is at 30. Right here, so 30. Next one is at 53. It's 50 here, so 55, that's a 53, maybe about right here. 53. Put the next one there, so. And you'll complete that box. Complete this box. Last whisker done at 75. 75 is right in between the 70 and the 80. 75 is around here. And then it's connect it. And you connect this as well. And if I can put the values on it. Right on so 15, right here 21.5, right here 30, right here 53, right here 75. This one is what kind of skew? Huh? Positive skewed. And everything on the right side. So it's positively skewed. Positively skewed. All right, guys. Watch the video. Next class is probability. So watch the video. So watch now. Now watch statistics video still enough. And then watch the probability video. See? We are coming next class. I was student and probability question. I will assume that you watch the video. But the list is in the video. And it's my list. Right, man? Cool. All right, guys. See you Tuesday. Huh? If you have a marker, one of them, graduate. Yes, I'm big man. When I come back Tuesday, come on. When I come back Tuesday. Yeah. Most fine space. Most.